give me brief overview about whatever we have discussed as of now. So we have seen all the application layer content and RT and what and all the things will be coming in the BSW. Yesterday we have seen all these modules. So today what we are going to majorly discuss is so the application layer. So majorly we are going to see like the application layer, how exactly the software components will be get configured in the different tools. It will how exactly the coding will be happening in the application layer. As we discussed yesterday, the application layer majorly it will be having the coding for the features like airbag application or the autonomous emergency braking or lane keeping assistance, lane departure warning. That kind of coding will be there, which will contains both auto generation and manual coding. And later we will be seeing at the RT configurations, so which will be having the different kinds of ports or interfaces. The ports are like sender receiver ports, client server ports or calibration ports and all those things. And also in the BSW we will be going to see the COM stack and the DCM stack, diagnostic stack I can say. In the COM stack, basically we are going to look at the from application to the COM, the message will come from COM to PDR, PDR to the CAN AF to CAN, it will be traversing. From CAN, it will be going to the physical CAN bus. Okay. This is for the CAN message transmission. In the similar way, we will be also going to see the reception also. Okay. And then the DCM part I will be going to explain from DCM in the sense diagnostic communication manager, from diagnostic communication manager to PDR, PDR to CAN TP to CAN AF to CAN, and also then finally it will go on to the CAN physical layer only. So you might have understood by the CAN and UDS protocols, like a CAN and UDS protocol called classes, that these both are the different protocols, but they will be working on the same CAN network itself. So the CAN network, what I'm saying is the physical layer. Okay. Then now we will be going to see like what and all tools we will be using it for the Autosar configurations. So basically guys, this Autosar is just one concept. Okay, automotive open system architecture. Okay, this different vendors will be giving their different packages. We call them as a SIP. That all those things we will be seeing it now. So basically we will be seeing the two main tools, which is a DaVinci developer and DaVinci configurator. So what and all inputs is needed, and like from where we will get that inputs is what we will be going to see it. So let me show the how can I make it big screen? Huh? Now at least it's a little bit fine. Hello.
No, Lokesh, it's like same like that only, just small words.
Is it what can I do here? No. Yeah, at least you could not able to see at all what it is there exactly. So this side these two things are there, right? This is not going. What can I do? Remove temp from the color. Hey, no, yeah. Pin temp to remain screen. No. What should I do? More options. So at least in your case, you cannot make in Skype. If you go and make it big screen, okay, that option was there when I shared last time. Okay, Pawan, how was it? Here in the view, you can go and make it enter full screen, okay. Then you will get the little bit bigger one. No, it's not possible. Huh?
No.
Hey, what about others here?
No, sir.
It's visible or manageable?
It's manageable, but what's a little bit blur?
Little bit blur also
Maximum
there, huh?
blur also there.
What should I do then? Then, guys, can you do one thing? I will just share. What is that? Google Meet link immediately. Can you guys join there? I think there it will be a little bit good. I don't think so. Last time it was manageable here. We have tried this already. We have done one class on this.
Yeah, Lokesh, when it is Zoom, it is okay, Lokesh.
Huh? Zoom. Zoom I doesn't have the
Yeah,
recording option there. That's the reason.
we have the Zoom option.
Guys, can you try to make your screen like this? Just click on this view if you are on the laptop. View and make it enter full screen.
So by clicking 1.5 into X, you can zoom the screen, sir.
Sorry, can you repeat once again?
Actually, at the right side, there is a screen size 1x or 1 into or 1.2, like
Where
1.5 like that,
exactly?
sir. Right side, sir.
Right side, this one only, right?
No, sir, actually. I'll share photos in WhatsApp.
In the Teams, sorry, in the what is this? Skype or in the Google Meet?
No, sir, Skype only, sir. 1 minute, I will share the photos.
Okay. Audio video settings.
Right side, look, sir.
Enter full screen is what I could able to see.
I have sent in group, sir.
This option is there in the laptop or laptop it looks like, but for me, no, I'm not having anything here. You can see it, right? I'm getting these options only.
Yes, sir. But for us, we can do, sir. Actually.
Nikunda 1.5. How can you are getting? You guys can make it, right? So I am the presenter, right? Maybe that's the reason I will not be having the option. Okay, you guys can
Yes,
make
sir.
it large.
We can zoom, sir, by clicking that.
So if I'm sharing my screen also, I think he could able to see now.
Yes, sir. We can zoom.
Yeah,
Sir.
it's fine.
Now you could able to manage, right? At
Yeah.
least
Yes, sir.
make.
Yes.
I'm just trying with one of my friend's laptop here by double logging in. So you can make 1.5. Okay, and that option is working fine. I could able to say at least in his PC it's working fine. There is no issue. Got it, right? Any others having any problem? Yeah, thanks, good Lakshmi. Thanks for that option.
Sir, I'm Bhavya, sir. Now.
Sorry, Bhavya.
Okay.
Sorry.
Now,
Guys, it's fine, right? Shall I proceed ahead?
Yeah. Yeah, Lakesh.
Yeah, fine. Thanks, yeah. Thanks for inputs. So basically, if you see, right, I'm sharing my notepad. Okay, I will be telling whatever the screen I will be sharing it out. Okay. So basically, if you see this DaVinci developer and configurator, these two are the tools which we will be going to use in the entire Autosar configuration. If we are getting the zip from the vector, zip in the sense software in package. Okay. Yesterday we discussed it, right? So basically, if we are having any of these things, like this BSW components, this entire BSW thing will be the pre-configured. So basically, they will be giving they will be giving options. Okay, if you are enabling that option, then one part of software will be enabled in their packages. So this will be given by the vector itself. Primarily, most of the OEMs or the vendors, they will be taking it from the vector. This is what we call it as a SIP, software in package. So this entire BSW we will be going to get. This is the base software. Whatever the application you are going to write it, so it should have some base, right? The OS, it should be there. If it is automotive ECU, then definitely it should have the DEM, FIM, date. All these components should be there. Okay. So this is a standardized base software. So vector knows that what it should be there. So similar way we have seen yesterday, right? So hey, what is this? What is this? So similar way, vector KPIT is having their own SIP. Okay, KPIT is having they call it as a KSR. Okay, for Autosar only concept is Autosar, but different companies, they are having their own SIPs. So vector, if you are getting SIP from the vector, we call that SIP as a microsar. Okay, vector SIP we call microsar. If you are getting SIP from the KPIT, we call it as a KSR. If you are getting from the Mentor Graphics, Mentor Graphics is one more company which will be provided this BSW. Mentor Graphics, they call it as a Mentor SIP. And we do have from the Electrobit, which is a part of Conti right now. Even they do provide the SIP. They for them they will call it as a EBIT resource SIP, EB SIP actually, Electrobit SIP. So for if these guys are providing the SIP, then we should use their tool, which is EBIT resource. If you are buying the SIP from the Mentor Graphics, then you should use the Mentor tool. Their tool name itself Mentor. So if you are getting the SIP from KPIT, they do have their own tool, but I'm not sure what is the tool name. If you are getting the SIP from the vector, then we used to use the DaVinci developer and DaVinci configurator. But most of the companies still now they are believing that vector is the a better tool, a better SIP package which they can believe in them to get the better BSW software. Okay, getting it right? Any doubts till now?
No,
So
no,
basically, I am not having any of these KSR or mental graphics or A/B tracers. I have the only vector sheet. For that vector sheet, we have the DaVinci developer and configurator tools. So that we will be looking at now. Okay. So if I am getting the software from vector, okay, if I am getting the zip from the vector, so then definitely we are going to use their tools, right? If we are going to use their tools, they need to give the .exe file to install their tools. So this .exe, even though if you have installed it, to work on that, we should have the license. Okay, this license, either it might be dongle based. Dongle in the sense the USB type. There will be a small SD card type of, not SD card. What is that? Yeah, pen drive type of one dongle will be there. That we will be connecting it to the USB port of our laptop. Then it will fetch the license from there. Okay. Or it might be software based also. Most of the times we will be depending on the dongle. If this dongle is connected, then only we will be able to open the DaVinci tools. Okay. So if dongle is not connected, then you cannot make any of the configurations in the DaVinci, any of the DaVinci tools. So this dongle cost is 10 lakhs, more than 10 lakhs sometimes. Depends on what components you are asking it. So we have seen multiple components, right? Not only these things. So let me show you the full diagram. I'm not sure whether I have the full diagram or not. So it's a depends. Okay. So for example, in my current project, I don't want to have the crypto services. Okay. If I'm removing these crypto services, then there will be a less amount for the license. If I don't want this Wi-Fi communication, then I will remove this tag also. Then still amount will reduce. Inside the communication, if I don't want to have the flex handling, it will reduce the some amount. If I want just the CAN and DCM part and the Ethernet, then still it will be costing little bit more. In the system services also same. Like how many components are the models if you are going to add depends on that they will be going to charge. Okay. It can, I cannot say that it will be constant amount for that license, which is a 10 lakhs or 15 lakhs or something like that. Okay. And again, there will be a different license. One is only for the configurator. If you want to have the license, that also they will provide. If you want to have the DaVinci developer license also, they will be providing separately. If you want to do any RTE configuration, then definitely you should have the DaVinci developer license. Okay. So we are looking at the what and all inputs we will be expecting for these configurations. Okay. So one is the exe file which we will be installing on our PCs. This exe is for both configurator and developer. Okay. This vector itself they will be providing to us if you are paying this much amount, and also they will be providing support also. If for example we brought the entire CAN stack, if there is any issues from the vector stack, then they will be providing the support. Okay. With the free of cost. Next, the second one is from the OEM. If you have any CAN communication things and all, then sometimes they need to provide the ECU extract. So this format will be in the .AR.XML file. So if any of you are from the CS or MCA background or any computer applications background, they must be knowing that this XML, right? So this XML for Autosar, we make it as a AR.XML. So there will be XML language which we no need to understand it at all. So we will be just looking at by seeing that we will be getting know what is this. Okay, no issues at all. You no need to understand. Basically, the programming language what you need to know is like only C language. Apart from that, embedded C concept you should know. That's all. This ARXMLs and all, if you are seeing for one time, then definitely you will be understanding it. So this ECU extract is needed. If you have the diagnostic implementation, then CDD part, this CDD is different. And yesterday also I wanted to tell that, but I don't want yesterday to be make it very complicated. So there will be two terms in the two places we will be calling CDD. So one is at the BSW. So here you can see this is a complex device driver, which is a module in the Autosar architecture. but the one which I'm telling it as a input file, inputs to the DaVinci tools, which is a Candela Studio, Candela description file, Candela description file. Okay, these two are the two different entities. Okay, so apart from this, what else we needed it? So that's all I think so. This majorly this inputs it is needed. This is from the vector. This customer may provide or may not provide customer input. This is from the OEM. If they are not going to provide, definitely if they are not going to give the issue extract, then they should give the DBC files, CAN database files. Okay, so you might have seen these DBC files in the CAN or UDS classes. This will be having what and all messages are going to configure in this particular project. So that basically the customer has to give. Why exactly the customer has to give is like, our ECU is just only one ECU in their entire vehicle, but they will be having 100 numbers of ECUs. Okay, so that 100 numbers of ECUs, how they are going to interact with each other is what they knows it. We cannot define that communication path. So that's the reason ECU extract or the DBC they should be providing to us. Okay, this is from the customer. Next is the CDD, Candela description file. This might be from the customer or from the tier 1 supplier, which I call it as a Conti or Bosch or ZF or whichever it will be. Or these two are the majorly providers are active also. So for tier 2 like L&T or the what others, the Ciant or any Capgemini or all these guys, they will be getting it from these guys, tier 1 guys only. Okay, customers, if they are getting direct projects from the customer, then definitely they will be getting it from the customer. If not, tier ones will be the one who will be providing it. Okay, and one more input guys. So from now onwards, we will be looking at more vector tools itself. So for you might have seen already the Canoe, which is for the CAN simulation, and Candela Studio you will be going to see it, Candela Studio, which is for the CDD file modifications. And DaVinci anyhow we are going to see it, DaVinci developer and configurator. And for reading this DBC files also we have the CAN DBC file, CAN DB plus something tool is there. So all these are from the vector only. These all tools will be provided by the vector. Here, apart from this Candela Studio and DaVinci tools, everything is open source. You guys can install it and you can feel it. Okay, getting it right? Any doubts? So we saw it, what is the inputs needed it, from where we are going to get it for these different kinds of tools. And this RT configurations and application software. First we will start with application software, then RT configuration, then BSW we will see it. Okay, fine. Let me, I'm going to share my, what is this? Google Meet. Okay, so guys, this is how, so let me show you like, guys, are you able to see my screen, right?
Yes, sir.
Yeah.
Yes, bro.
I'm trying to make it little bit big screen, entire full screen. And though this one also, is there any other possibility which I can make? This is Google Meet is a worst tool. Yeah. I cannot access apart from this Google Meet anything in my laptop. That's the problem. Hey, what all these things nonsense? This if these two are going out now, then definitely we will get a lot of minimize. Correct. This how can I minimize? I need to remove this guy. Huh? Let me see here if I have any option to minimize it. Minimize. Till it is showing. No? It's okay. Sorry, I cannot make this much more than this. Okay, please bear me with for this particular setup, at least for today. Okay, fine. So first what we need to see, we might have received the vector zip, right? So how we will be going to install it? Okay, I'm not sure whether I have that vector installed file or not. So yeah, this exe you will be going to get it. Almost it will be 7 GB, 8 GB, something like that. Okay, this CBD they will call it as. I am calling it as a zip software in package, but they will be sending it the CBD 21 version, or they will be having their own version names and all those things. That's fine for you. It depends on the project. It will not be same for everything. If I am installing this exe, so it will by default it is going to install inside the vector file, vector folder, which will be there in the Windows C. Okay, so this is my zip package. Okay, so this zip package, already I told, right? So from vector, whatever the base software which they are going to give, all those things will be there in this file. Okay, after installing that exe, I will be going to extract all the software whichever they have developed from the vector side. Okay, so if you see at the DaVinci configurator, so core, so this is the exe which I am going to use it. So I have opened it, I think. Let me close that first. Okay, fine. So this is the exe file. I will be just opening it. This will take little bit more time to open it in the background. So let it open in the background. So then you can see inside what and all will be there. Okay. So if you see the configuration parameters, all these things are, some INI files and DLL files and all will be there. Don't bother about that. The licenses, whichever it is there, it will be there in this TXT file. This is a software-based license for me. At least for this DaVinci configurator, it is a software based, but for developer, I have the dongle connected in the laptop. Okay. So plugins and all, whatever they needed, they, by default, they will be giving it. Don't worry about that. And then documentation, previously, all the documents for, so yesterday we have seen one kind of documentation that is like open source document, which is not a project dependent. So it will have what and all possibilities which we can do in that particular module. But here, whatever after installing your CBD or zip package from whichever you have received it from Vector, it will have the documentation which is specific to your project. What kind of configuration Vector has given is what it will be having it. Okay, you can see here the components. So all these components are what we are going to get it from the BSWM. Sorry, from the Vector. So BSWM, CAN IF, CAN NM, CAN SM, CAN TP, CAN transceiver, CAN XCP, CDD, complex device drivers, COM, CRC, DCM, DEM, DET, and Ethernet related files, and fault inhibit manager, IO hardware. All these are the BSW models which we have seen it yesterday. You can see here. I'm sharing my OneNote. Okay. It's not going up. Huh? Why? Yeah, just give me 1 minute. I will get one more mouse. Okay. Sorry. Guys, I'm back. So what I was still, hey, what happened? This is what I was showing you. So all these modules are there, right? So but these modules we have not we how we are organizing is what we will be telling, right? So here it will be in the very organized way, okay? But if you are coming to your project, so you have seen it, right? So it is not mandatory to have all these things in these folders itself, okay? From vector, whatever you will be getting, again at your project level, again you can maintain this however you wanted, okay? That also I will be showing it, okay? But from vector, once you installed it, right? So from vector, once you installed it, so it will not be in this similar way. You can see here, so it will be just coming as usual, okay? So all these things will be having these all modules already vector has done their implementation. That will be the some standard, right? So all those things they have done it already. So you can see the documentation. This is a technical reference for this project, whichever we have paid it. For that, they are going to give the technical reference document. Almost, I can say more than 80% it will be same as what you will be getting in the open source also. Okay, but only this configuration part is only for this project specific. But your open source will be having more details apart from the project specific. Okay, your open source, what I can say is open source document will be saying what and all 100% possibilities it will happen on that particular module is what it will be giving. But if I'm coming to this project level, it will be just giving like what it is needed for this project, whatever we have requested from the boss. Okay, so that is what they will be having at this documentation. Apart from that, they will be also having this implementation part. So this com.c. So all those guys will be giving this entire software. So it will be useful in our component, in our project. However, we wanted to have, see, for example, this function, they are giving it, okay? So this parameter I will be configuring in the DaVinci configurator. If it is a standard on, then only this function call will be happening. If it is off, then this function will not be get called in the real-time project. So this is how the vector ship will be. They will be giving option for us. Either you can make it on or off. Or else if you want to alter any of the values, that also you can perform it. So guys, any difficulties here to understand? I know it is a bit difficult. Still, if you are getting any confusion, just let me know. I will try to clarify it. If not, I will think that it's everything is going in the smooth way. Getting it? This is entire BSW is what we are going to see it now. This is the first step after installing the zip package which we received it from vector. What and all things will be there is what we are seeing it now. So this is one thing for the com module. The similar way for DCM also it will be there. Each and every component it will have all the documents on the source code and all those things. So this is how it will happen once you have installed the vector zip. I have installed two zips for the two different projects, so that's the reason it is showing two things. Okay, got it right? You have installed the vector zip. So in this vector zip, you have the already what is this? DaVinci configurator.exe file that I have opened it here. Okay. Okay. Only the DaVinci configurator you have opened it. To work on this configuration, okay, you need to have the different input file, which is a DPA file. So after doing the basic configurations, we will be generating one DPA file. So to that DPA file will be there in my project files, my project folder, I can say. So this is my project folder here. This is my project folder. So this is up to the project. It is specific to the project, what and all folders you wanted to have it. So for my project, we are having all these folders and all. So again, we will be seeing it tomorrow or day after tomorrow at the project level explanation. But now our concentration is for the Autosar configuration. So that DPA file, I needed it. That DPA file I will be having inside the software. So now you can see here in our project we are maintaining this kind of folder. So application layer. So this application layer, for me, we have the diagnostic UDS in the application. Apart from this, there are something else also that I will be showing. Cyber security related and some common configuration folders we are having in the application. Okay, this is not ADAS project, so that's the reason I could not able to show like the TSR, AEB, all those things. If this is ADAS project, then all those TSR files and all those things it should be here actually. Okay, then runtime environment. If RT related configurations, if you are doing anything, all those things will be get generated into the runtime environment. Okay, then service layer. Inside service layer, what and all the things we are having it. So this is the way how we are organizing the folders. Okay, this is Autosar based, so that's the reason we are maintaining the folders also in the similar way. You can see the communication services, what and all it is having. Security, IPDM, COM, DCM, DEM, all those things. So communication services, memory services, system services, all those things will be there as part of the Autosar. If you see here also same communication services, it will have the communication services in the sense like all the communication related CAN, UDL, CAN, Ethernet. If you are having the LIN and all those things, it will be here the folder wise. So these folders, they are copy paste of what we have seen previously, which after installing the after installing the zip, right, we saw these components, right? So all these components are here, okay, but we segregated in our project however we wanted. Okay, so you can see communication services only as per the Autosar, CAN NM, CAN SM, CAN TP, all these are the part of communication services. So that's the reason we have segregated all of them and we kept it in the communication services folder. So this is an entire copy paste from the vector zip only. We will not be doing any development inside this one. Okay, if you are doing any configuration changes, then these files will be going to alter, that's all. So memory services also similar. NVM we are keeping it. For system services, OS related, BSWM, COM, ECM, all these things we will be keeping inside the system services. Similar way, for the ECU abstraction also same, CAN IF, LIN IF, all those things will be there. For microcontroller abstraction, we will be having the CAN drivers and all those things. You can see here if you want. See CAN drivers, Ethernet drivers and all those things. So complex device drivers. So there is a one concept called UDS firewall, which is a kind of a security. So that it cannot be fall under the Autosar. So that's the reason we are keeping under the complex device drivers, which is a CDD. If there is any libraries coming from the vector or from the controller specific, all those libraries we will be keeping inside it. Then finally the configuration. The configuration is what? The vector configuration, the vector DaVinci and developer and configurator, what we will be doing the configuration. All those configuration air XML files and all, it will be going to generate inside it. Okay, getting it? So this is the DPA file. If you are doing at least one time the DaVinci configuration, so this DPA file will be going to generate it. So that is the file which we need to load it into the DaVinci configurator now. So already I have done once or twice. So that's the reason it is showing here. By default, the recent file whichever I have loaded. So you can see like C sandboxes, the project name on the 09 configuration vector config. This is a DPA file. You can see also here also. Sandboxes project name 09 configuration vector config. This is the DPA file. If you want to add newly, you can go here, file, open, and then you can do like 09 configuration. I'm not sure which project is this. This is the same one only. I can open it. Vector config. Here it will be showing DPA file. Okay. So I'm loading that project now. So that DPA file will be having whatever the configuration till now we have done it. So all those configurations, it will be there. Okay. So this DPA file is loaded now. So that's the reason it is showing all the basic editor, all these communication things and all those things, and diagnostic related here, memory related here, and network management here, mode management here, and RTE related it will be here. Okay, getting it. So if you want to have all of them at the one place, then I will be clicking the basic editor. You can see here. You can see here all the basic software modules are here. Okay. So from vector, what all I got is, so these modules I have the access. Okay. So apart from these modules I have enabled for my project purpose. But apart from this, if I want to add anything which we brought it already, so I can select from the software integration package, which is a SIP. Then if I'm clicking on next, it will give me all the options like what all other modules are already present. If I wanted any of them, then still I can go ahead and I can select all of that. Okay, I don't want to add any of the new modules now, so that's the reason I'm not going to select anything. Okay, got it right? Now, this is the base software modules. If you want to configure any of the BSW components like ECAL or service layer or MCAL, anything, then you need to go ahead and you need to do the configurations here. If you want to do any RTE configurations, or if you want to do any uh, software component, the application component configuration, then DaVinci developer is the one which you need to use it. This also will be coming from the vector itself. That exe file I doesn't have it now, but you can see later if in our project if you are getting it. Okay. Now for this also same, for the configurator we used it, right? DPF file. Here DCF will be there. That file we need to use it. Previously, whatever the configurations we have done it, all those configurations will be saved in the DCF. Okay. So particularly in this my project, I have this kind of application software component, diagnostics application. Diagnostics, for that DCM will be there in the BSW for, but basically it needed to have the logic implementation in the application software component. So that's the reason one SWC I have it. Okay. And issues IPsec, issue monitoring, IO hardware abstraction, end of line software component, IDS is the one software component. So basically I have these 6 software components which will be there in the application layer. Getting it? Any doubts still here? So this is creating application component is very simple. So you can create like new application software components, that's all. Then it will come one more software component like this. You can rename that, that's all. So now let me go to the diag app SWC. So before entering into that, I need to give little bit overview about the, what is this RTE one. I'm sharing my notepad now. Where is my pen? So most of the times in the DaVinci developer, we will be doing the RTE ports configuration. So we have seen it right in the high level. So this is the application. This is RTE. This is a BSW. So if from BSW, if you want to interact anything, then it should go via RTE only. If two software components which are there in the application, if they want to interact also, they should interact via RTE only, correct? So while interacting these port interfaces, we have 3 different kinds of ports, right? Correct? So this application component creation and RTE, we will be doing it in the DaVinci developer. DaVinci developer. Only these BSW configurations we will be doing in the DaVinci configurator. Getting it? Okay. While doing these RTE port connections and all, we will have the sender receiver port. Sender receiver port and client server port. Client and server port. Okay. So first let me see the sender receiver. So sender receiver, in the sense, I have the software component 1 and I have the software component 2. This component 1, 2 we will be seeing in the real time after this explanation. Okay, if software component 1 is having some breaking information, let's take this is a traffic sign recognition component itself, and this is a otherwise let me take one good example itself, which we are going to see it now itself. I don't want to confuse all of you about it. So basically, apart from this TSR, okay, I have the one. All of you know KL15, right? Which is a power supply line to the ECU. KL15 we call it as. So in our cars we have the battery connections, right? From battery to our ECU there will be one wire connection. These two wires will bring the power to the power supply to the ECU, which we call it as a KL15. Okay. So if KL15 is on, then only the diagnostics will be happening. Okay. Okay. So let's take this is a diag app SWC. Diag app SWC. And this is the ECU monitor SWC. Okay. So KL15, basically the status of KL15, whether it is on or off or whatever the voltage levels, 8 volts or 16 volts and all those things, it will be coming to this software component. This software component will be having the KL15 status. So now who is the owner of this KL15? This ECU software component is the owner. Okay, I needed it here in the diagnostic application software component for doing the some diagnostic content. Okay, so this guy is owning that KL15 status at the diag app SWC. I needed it. Okay, so for these two software components I will be going to create the sender receiver port. So now this guy is the sender, this guy is the receiver. Who is that? Diag app SWC is the receiver. I'm receiving some information from the ECU monitor software component. Okay, so in that case I will be going to use a sender receiver. Basically how it will be coming after creating is RTE underscore write, and at the receiver side it will be coming RTE underscore read. Got it? So these two are the interfaces which will be bringing it. The information RTE write will be providing the KL15 status, and RTE read will be reading the KL15 status. After reading it, then it will perform the diagnostics for your EC. Got it? So in that cases, we will be going ahead and we will be using the sender receiver port, which are part of the RTE. Guys, any confusion here? After this class, please go ahead and read this RTE software component document which are there in the open source. Okay, Autosar org. Okay, so this client server is like function call invocation. Okay, we saw it right in the C language explanation. If we will be having the main, inside main, if you are calling function 1, then it will go and it will execute the function 1 definition, whatever it will be having, right? In the similar way, so client is the one who will be invoking. So here in this case, client is the main and the server is the func1. So client, the main is calling the function 1, so it will go to the function 1 definition and it will execute it. In the similar way, this client server port also it will be executing it. Getting it? Guys, please be attention here. So all these concepts will be going to mess up at the end of the day. So that's the reason you should be very concentrated at this particular concept so that you will be understanding. If you are understanding one time, then this is a one time lesson for their entire what I can say experience. You no need to study once again all these things. We're getting it. So this Sender receiver also coming as a function call type only, but there is a one more concept called runnable. Does anyone knows what is this runnable? A runnable or a task in the embedded systems? Any idea? Any inputs? Even if it is a wrong, that's fine for me. Please open up your mouths. What does that mean? Runnable or the task or the raster? Any idea? Come on, guys. So basically, these guys also are the functions only, okay? Functions only. But they will be getting called every 10 milliseconds or 5 milliseconds or 1 millisecond or 1 second. It's a depends like however you wanted to call them. These functions will be getting called for every periodically. That's the reason they will be calling runnables, task or raster. Any of the term is same, okay? Okay, so this sender receiver call sender receiver ports basically they will be linking at the runnable. Okay, so runnable in the sense it might be calling for every 10 milliseconds. So for every 10 milliseconds, this sender receiver also will be going to execute it. But in the case of client server, it will not be happening in that way. Okay, this client and server will no need to execute at every 10 milliseconds. So whenever his client is calling, client's call, then the server will be get invoke and then it will execute the operation. Executes the operation. Getting it? Guys, getting see basically for developers all these things we need to concentrate, okay? So basically we will be having the different kinds of tools. It's not similar thing to the other IT jobs, okay? So for each and every task we have the one tool here, but you no need to be very proficient or the expert in that tool, okay? You should know the basics of that tool. That's fine. No one will be expecting you to learn about the tools in the automotive. If you know the concept wise, the tool usage is very simple. They all the tools are very user friendly tools in the automotive. Don't worry about what and all these things and all. So it's a very huge development process, right? So that's the reason we will be having the different tools. But anyhow, in the our end of the class, not today, our end of our this lectures. I hope we will be having the team will be planning for one class. So for the tools explanation itself, but I'm not sure when it will be going to happen. Only tools we will be going to explain in that class. What and all tools will be coming at the different development areas. Okay, fine. So here the client server is something like this. It is no need to run for every runnable time, either for 10 millisecond or 5 millisecond or something. Whenever the client is trying to call it, then the server will be getting invoke, and then the function execution will happen. Then the functionality will happen. It. So basically, if two software components wanted to interact, then in that cases we'll be going to ahead and use the sender receiver. If from BSW, if you are want to access any of the thing, like if you see from BSW in the sense from the DCM, if you are trying to access anything with the diagnostic communication manager, DAC communication manager. So from here, if you are trying to access anything, then basically I will be using the client server ports here. Client server ports. Okay. Got it? Guys, any doubts here? If no doubts, so we will be going to see the sender receiver ports. Sender receiver and client server ports, how we are going to configure it. Okay. Got it right. So I'm going to share my DaVinci tools now. So now we have seen it, right? So what we have seen is like all these application software components. I have it, tag app, tag app, SWC, and all those things. ECU is IPsec. So diagap SWC, ECU is IPsec, ECU monitor, and all those things are the software components which I am having it. So diagap, sorry, diagap SWC, if you are opening it, so just now we discussed about the KL15 RTE port, right? So this KL15 RTE port, we are having it here. So if you can see here, this is a sender receiver port actually, okay. So I'm making diagap SWC is the receiver, okay. Who is the provider for this? The ECU monitor is the provider. You can see even ECU monitor will also be having KL15. So this KL15 is the sender here. So this guy will be sending it and the diagap SWC is going to receive it. So this guy is going to receive it. So this connection is happening. So before that, what we will be doing is port prototype is needed it actually. Application port interface we will be creating it. KL15 line. This KL15 you can see. So this KL15 is needed to have the sender receiver port. This is needed for the creating sender receiver port. So this will be the base for both of them. If I'm double clicking on this, it will be having what and all data elements it is going to accept it. KL15 status is the port name what I'm going to give. Whatever the data it is going to hold it is what uint 8 type. So unsigned integer 8 bit is what it is going to access it. Okay. So by taking this interface as a base type, I have created the two port prototypes, which are the sender at one side and the receiver at one side. Diagap SWC is the receiver, ECU monitor is the sender. Getting it? So those two guys are getting connected. So that's the reason. So they will be getting created the one particular port. So you can see in the diagap SWC. So the diagap SWC is application component, right? That application component, it will be generated inside the application folder here. Source. If you are not specifying any of the other path, then it will be get generated inside it. These all are the temporary files. I don't want it. So that's the reason I'm deleting it. Okay. So this diagap SWC is the component which we were looking at. This is basically for the diagnostic application implementation, which I will be doing most of the things. So here you can see, if I search with this particular name, what was that? Diagap SWC. If I see this KL15 name, right? ECU monitor KL15, I will be getting it here actually. What happened? How we will generate and all, I will be telling it. Okay. ECU monitors SWC KL15. So can anyone tell me what is the whether in the diagnostic application SWC, whether it should be the RT read underscore or RT write underscore? However, how it should be there? So as we discussed earlier, so at the receiver side, it should be the RT read only. So ECU monitor will be providing it at the diagap SWC. I will be just reading what is the status of KL15. KL15 in the sense this is the battery management, battery monitoring. What is the status of battery? Battery is switched on or not or something like that. So you can see KL15 ignition status from the ECU monitor SWC. Okay. So if I see the similar thing, RB underscore ECU monitor KL15 status in the entire project level. So RT write should be there in the ECU monitor. Okay. It's already generated. That's the reason I'm just showing the already generated ones. Okay. You can have just an overview of it in the software, how exactly it will be coming and all those things. Don't bother about these RT files now. I will be telling what is that about. So if you are generating from the DaVinci, it will be generating a lot other files also. So you can just concentrate now only RT write and RT read. So here you can see RT read. ECU monitor SWC is the one particular software components where it is having the RT write. So this is how RT is going to interact. So for example, tomorrow if you are going to delete this ECU monitor, still there will not be any effect to the software. Why? Because these two are the individual software components, but definitely this information you might be getting it from the some other software components. So what is the main motto of Autosar? All the modules, either if it is a software components or the BSW component, it should be independent of other one. If you are removing the one software component, then the software should not be crash. That's the main motto. So if you are removing tomorrow ECU monitor SWC, then you can just go ahead onto your SWC and you can just disconnect this connection. That's all. It will happen. If you want to connect this connection to the any other software component, go ahead and create the one more new port in that particular component and connect it. That's all. It's a very easy way of doing it. If it is a manual coding it, then if I'm deleting here, we don't know like where and all it is going to affect it. If for example tomorrow if this ECS monitor SWC component itself, if it is not there in the application layer, then we can understand that what and all it is going to affect it. Okay, you can see on the high level, ECU monitor is basically is going to interact with these many other software components with particular ports. So guys, within a month or something like that, you will not be getting these things. But anyhow, all of you, I hope think so. The team will be restricting you to tell like you will be having just experience into the application layer. No one will be telling that you have worked on the BSW configurations and all those things. So it is just for your basic overview only. Okay. It is overlapping. How can I make it? No, it's not coming. But basically, see, these are the interfaces you can see, right? This particular diagap SWC is going to take all these inputs, okay, as a receiver. Okay. So this is how the RT, sender receiver port will be getting generated. So one will be the RT write, the other one will be the read. The RT write in the sense sender, and the RT read in the sense those guys are the receivers. Okay. So in between a lot many RT files will be getting generated. You can see RT application core, RT hook, RT type and all that. If I'm telling now, you will be get confused. But I don't want to tell all of that now. You will be getting understand like if you are getting into the project. Okay. In a similar way, now we are going to see at the client server ports. Okay. So client server also, if you see, like we have discussed already, right? Client server basically from BSW to the application layer. If there is any interaction, then we will be having the client server ports. So in the diagap SWC, I have the DCM interactions actually. You can see like they will be coming as a server ports, service ports actually. So can anyone tell me any one of the DID which you will be remembering? She might have told in the class, okay, UDS or the CAN classes. So these all are the DIDs, data identifiers. Okay. So this data identifier, so if any of the tester is requesting to read the information, till DCM we know it will come. After coming to the DCM, it should come to the application layer, right? To come into the application layer, these are the client server ports which I am creating to fetch any one of the information. Let's take any of the, EC serial number you can take. Okay, where is that? No, I don't want to take the EC serial number. Vehicle identification number you can take. Vehicle manufacturer ECU hardware number. Okay. So for each and every ECU, vehicle manufacturer, they will give one hardware number. That number will be get stored into that particular DID. Okay, you can see here. Now this is the server. Okay, this is the server. So which will be get created into the diag app SWC. So who will be the client? Can anyone tell me who is the client here? Who will be invoking this operation? So basically, let me tell you the flow how what is happening here. So now you have the one tester tool. So you have your ECU here. ECU. You have connected this tester tool via the CAN communication. CAN communication with the two wires. So here inside your ECU you have the software, right? Inside your ECU you have the software. So in this software, what we are doing, we are developing that into the application, RTE, and BSW. So inside BSW, for diagnostics, basically what and all components we needed it. DCM is one, and COM we needed, and PDR we needed, and CAN IF we needed, and CAN drivers we needed. So these CAN drivers will be connected to your microcontroller pins. These pins will be connecting to your CAN communication, whichever it is coming from the tester tool. So this is how, this is the hardware. Okay, this is hardware. This is the hardware. This is the software. This is the software which is flashed into your microcontroller. Okay, getting it? So whatever the request you are coming here, there will be two pins in the microcontroller. With the two pins, it will be going to the CAN drivers. From CAN drivers, the software will route it to the CAN IF. From CAN IF to the PDR. From PDR, it will go to the DCM. So you have requested 22. What is the TID number we have seen is vehicle manufacturer ECU hardware number, which is F191 DID number. So what request you will give from the tester tool? So 22 F191 we will be giving it. Okay, this is the request from tester tool, we will be giving it. So 22 F191 till DCM it will come in this path. Okay, got it guys? Any doubts here till here? 22 F191 if it is coming to here, then DCM knows that this will be serviced by the application only by using the sender what is that, client server ports. Got it? So to service this port, to service this particular 22 F19, guys, you are seeing my OneNote, right? I'm sharing my OneNote actually. Are you seeing OneNote or the DaVinci tools?
OneNote, bro.
Yeah, then it's fine. So 22 F191 means what? This is 22 is a read data by identifier service, which you have studied already in the UDS protocol. Read DID. So which it is bringing the F191. F191 is about ECU hardware number. So ECU hardware number basically will be provided by the application. In the application, what software component we have? Diag app SWC is the one. Diag app SWC. So what we have seen it in the client servers. client will be requesting for some information and server has to invoke, and then server will be providing that information, right? So in this case, my question was, who is the client? Can anyone tell me now? Anyone is there? Guys, even if it is a wrong also, it's a fine. I just wanted to understand till where you guys are getting a guys, any inputs? Who is the client in this case? DCM or Diagap SWC? DCM is the client actually. Getting it? So DCM is going to act as a client, then Diagap SWC will be act as a server. So that's the reason you will be seeing it here. In case of diagnostic application software component, this F191, the report whichever I have given as a server. Okay. In case of DCM, it will be the client. That connection you cannot be seeing here in the DaVinci developer. That connection will be there in the DaVinci configurator. So in the DCM, I have the service ports concept for here. So here you can see like F191. Diagap SWC is the connected component. So this guy is a client. Diagap SWC is a component. I mean the server. Okay. Getting it? This is how the client server ports we will be connecting. This is how they will be getting used in the real-time projects. Guys, any doubts? So as we discussed, DaVinci developer basically for the SWC configurations and RTE configurations. That's all. And to generate the code and all, the DaVinci configurator is the one which we will be using it. Just give me a minute. I will be back. If anyone wanted to take the break for 2 minutes, you can take. Guys, I am back. So this is what we were seeing actually in the DaVinci developer and developer. What we are going to see is like only the RT configuration and SWC's creations and all those things. But at the end of the day, again in the DaVinci configurator itself, we will be going to generate the software. Okay. So how to generate and all those things, I will be showing it at the end. Guys, any doubts still here? I will be showing now the BSW configurations now. Okay. Now let me show you that. Now we will see the DCM configuration and one CAN message configuration. Okay. So inside DCM, so here in DCM, how the exact communication is going to happen, we are seeing here, right? So from tester tool, it will come to the CAN driver to CAN IF, PDR, and then to the DCM it will go. Okay. PDR is the one who will be deciding to where it should go. PDR in the sense PDU routing. Okay. So PDU routing, it may go to the COM or to the DCM. So it's a depends. If request to the DCM, then it will go to the DCM. If it is a normal CAN message, then it will go to the COM. Normal CAN message reception, if it is, then it will go to the COM. Okay. Any doubts here?
No.
Yeah. So now we'll see step by step, like see basically in the CAN communication, CAN drivers. So what kind of configurations we will be having is like, what are the information we will be receiving on that particular CAN channel? What is the baud rates? Uh, See basically what CAN controllers we are having it. CAN controllers we are having it. For that CAN controller, what is the baud rate? And if it is having basically the CAN driver, basically it will be having the hardware objects also. Hardware objects in the sense it will also have little bit memory actually. Memory. So we call it as a hardware objects or the buffers, hardware buffers. Okay, that hardware objects and all we will be configuring it here. For if you are receiving any of the data from the tester tool, right? So then first initially you need to store into the hardware object here in the CAN drivers. Okay, and how much speed you are receiving, that communication is going to happen in that particular CAN channel is what we will be telling in the baud rates. So definitely she might have told that in the CAN communication class. Okay, and then in CAN IF, what is the CAN message ID we are going to receive in the CAN IF? What kind of message, what is the message ID we are going to receive? Apart from that message ID, if you are receiving anything, then it will not allow to the upper layers. Okay, so if message ID, whether this is a standard or extended, and from which hardware object we are going to get that data and all, we will be linking. So guys, all these modules will be linked with each one. Okay, CAN will be linking only with the CAN IF. From CAN you cannot link with the PDR. From CAN we cannot link with the PDR. CAN will be linking only with the CAN IF. CAN IF can link with the PDR. PDR can link with the DCM. Okay, that flow you guys have to remember it. Okay, then CAN IF, it is holding all this kind of information, like what and all RX messages it is going to receive, what and all TX messages it is going to receive, what is the HRH, HOH. These things I will not be telling now. You will be get confused. Only this part I will be telling. Okay, then next is the PDR. PDU routing. PDU routing. Okay, PDU in the sense protocol data unit. Protocol data unit. Okay, so in the entire Autosar, we will be having the different PDUs actually. So if you know the OSI layer, right? So what and all it will have? Physical. Then what else next? What is the next? Data link, network, session, and in between this network only transfer protocol, session, then presentation, application. 1 2 3 4 5 6. One more is missing. Which one is this? Physical data link. One more is missing, but I'm not sure what is that. Okay, so this each and every layer will be having its own protocol data unit. Okay, so the actual payload what you wanted to transmit is, in case of diagnostics, 22 F122 F191, I think, that is vehicle manufacturer number. So this is a payload which you wanted to transmit to the DCM, which is to the presentation layer or the session layer. But here network protocol, it will have its own headers actually. So that header will be appended to your actual payload F192. You know the CAN protocol, right? It will be having the start of frame, and it will be having the DLC. It will be having what next? What is this here? This is not DLC. This is arbitration field. Arbitration. This is the DLC, which is the data length and all. It will be having, which is a control field, and then it will be the actual data field, which it will have the payload which you wanted to send it. And next will be the CRC, next will be the ACK, and next will be the end of frame, I think. So to transfer this payload, we will have the some arbitrations and all those things. So this arbitration, what it will hold? Message ID. Okay, this message ID, how much length it is going to have, what is the payload, what is the CRC, what is the acknowledgement, and all those things we will be sending it. So this PDUs will be differing in the different layers. Okay, so in network layer we call it as a NPDU. In the session layer we call it as a SPDU, SDU actually. In the data link layer we call it as a LPDU, link PDU. Okay, this data link layer, whatever it wanted to header, it will just header it. So actual PDU is what, this one only, the data which you will be going to send it. So first it will send you the SDU. For that, a network PDU header will be included. For that, then data link layer PDU will be that means like header will be included. Then finally it will become the LPDU. Okay, that PDU information and all will be holded. In the finally, in case of reception, it will come to the CAN driver. In case of transmission also, from top to bottom it will go, and it will sit into the CAN hardware objects only. So now the concept where it is a PDUR. What is this PDUR? Protocol data unit routing. So from till now, from you are receiving from either CAN IF or something like that, right? So it will be coming to the PDUR. So from PDUR will decide whether it should go to the DCM or to the normal COM. This routing we will be configuring in the PDU module actually. Okay. Now, if it is coming from CAN IF, then it is a CAN communication. If it is coming from the LIN IF, then it is a LIN communication. If it is coming from the ETH IF, it is a Ethernet communication. Okay. Got it? So inside DCM, again, we will be having the all RID, DID configurations, or UDS services configurations, and all those things. That is what we will be going to see it now. Any doubts here, theoretically? No, right? If no, I will be showing now like one particular CAN message. Okay, not CAN message, DCM request. So basically, so we have seen here like this is going to act as a server, which is a vehicle manufacturer issue hardware number. Similar way for all the DIDs or RIDs, it will be there. Okay, don't worry. If you just try to understand one particular simple thing, then you will be going to get to know about all other things also. So DCM, which will be going to the application software component. So in the DCM also, we will have the configuration for that. So here you have seen it, right? In the issue software component, service component, service ports, you see it. This is under the DCM. What under the service ports it is having? These many service ports it is having. So this F191 is going to connect with the diagap SWC. The similar one also you can see in the basic editor, the DCM. Don't worry about DST, DSL and all those things. I don't want to confuse with all those remaining containers. You can, if you want anyone, you can just search DCM Autosar document. You will get to know what and all this DSD, DSL, DSP. Okay. So now the DID information will be there here. Okay. So this is just like Autosar configuration. We are doing it. If you are doing it, then how exactly we will be doing in the application? The manual coding, what we are going to do is what I will be showing it. Okay. Now I am just searching with the F191. So F191 read component is the I don't want in this way. I will go ahead with this one only. Okay. What is that? F191 is DID vehicle manufacturer issue hardware number. So here you can see. Okay. So this is going to interact with the this signal, what kind of read, what kind of accesses this DID will be having onto that kind of information we will be sending it. So this is like a user element specific interface, which is a client server interface. Okay, so now you can see here DID info information. So what kind of information this DID is having, that linking we are giving here. So if you want to see show in or show referenced item in the basic editor tree, it will go to here. So which is a part of same DCM itself. See, for basically for one DID, what and all information needed here? For one DID, if you want to configure, so what is this kind of, what this DID read and write, if it is going to support? So what kind of sessions it is going to support, like whether it is going to support in the extended and default and also in the programming also. And apart from that, what is the DID number, and what is the length? So this kind of information only we need to configure for one DID, right? So that entire information we will be configuring here. Okay. Now you saw it, right? We have just given that DID is read DID. That information is not at seen. You can see here like, so DID access. What kind of DID access it is having is only read access it is having. So if it is just read means, then what and all sessions it is going to support is like uh, read session support. It is not linked anything, but basically you can link what and all supports it is going to support, what and all sessions it is going to support, whether it is going to support default, extended or programming. If you are linking that, then in the software also it will be going to generate in the similar way. If I'm keeping this like it is going to support for the write also, then it will generate in the similar way. Got it? Let me make it, it is going to support for the write also, DID write also. If you are trying to generate the code, then you will get to know what it is going to do it actually. DCM write, DCM. So and also this session is going to support only in the extended session I am keeping. Writes basically will be supported in the extended, and write always will be having the security levels also. I am giving the level 1 security access for that. Okay. So I will be saving it here. For F191, we have created the write access also, the DID write. Okay, and then we will also have the DID data infos. Okay, so if you see the F191, what is the DID number and all those things, it will be there in the this one. Hey, where is this one? Here you can see. It is not having anything. It is having just a DID length at 128 bits. It is, and DID number must be there. I don't know where it is exactly. It is referring to basic editor, this one, but it is not having any information. But I saw somewhere F191. Not this one. This is access actually. Here DID number will be get configured here. So this kind of information it is required basically for the things. If I'm deleting this, okay, this is a very intelligent tools. Okay, whatever the vector is providing, they are very intelligent tools. Whatever the mandatory information is required to configure one of the DID, you should be providing all of them. If you are not providing any of them, then it will throw an error. If I delete this one, right? Now it will throw an error. You can see in the red mark it is throwing an error. Invalid multiplicity. So mandatory parameter, this is you are not creating it. So that's the reason it could not able to generate the code. Even if there is a single error also in the configuration, then it will not generate the code. Okay, now almost all the automotive tools are automotive software is going into the tools. Why? Because to mitigate the manual errors. So that tool is very intelligent now. It is not. It will not allow you to, generate without that configuration. Got it. So this is the DCM configurations I have given it. So basically, to this DCM, the connection from where it will come from the PDR, right? So at the DID level, the connection will not be coming it. So the DID level will be handled inside the DCM itself. So for DCM, only one PDU will be coming from the below layers, which is a PDR layer actually. So what is that PDU? So that PDU configurations we will be doing in the DSL of DCM. Guys, you cannot remember all these things until unless you are studying this DCM document, okay? So basically this UDS protocol I am running on this particular channel. So if I see here, it will be having one PDU information actually. That PDU is what I wanted it. So physical request, if I'm giving it, that physical request, it will be coming on this PDU. I wanted to see this PDU where and all it is getting used, okay? So this, if I'm doing the element usage, then I will get to know where and all it is getting used, okay? So it is getting used inside the DSL and inside the PDR and inside the CAN TP. That's all. From CAN TP again, it is going to change it. Why? Because it is a different protocol. Okay. Now let me show you on the PDR how it is going to route into the below layers. Okay. So in this case, PDU. Yeah. So in this case, from CAN TP, you will be receiving the request. Whatever the information you will be receiving from CAN TP, that information will be copied into this PDU. This PDU will be routing to the destination, which is to the DCM. That's all right. Hey, sorry, I'm not sharing my screen. Sorry. So what I was telling is, so what I was doing is like in the DCM DSL protocol, I will be having the physical layer. So here I will be having one PDU. This PDU basically will be linked with the below layers also. If I'm seeing it, so basically here is what we will be having it all the PDU. If I'm doing this element uses, where and all this PDU is getting used is what we will be going to get to know. So here basically if you see the PDU or DCM CAN TP is the one where we are going to use it. DCM, anyhow we know it from to the DCM, the diagnostic request is going to happen. So to now to PDR it will be going now. So PDR will be deciding, hey, sorry, PDR will be show reference item. Why it is in the two? Okay, if I'm doing it, I don't want ECUC now. So if I go to the PDR module for this particular PDU where and all we are referring is, this is the source. Okay, basically if you see like from the CAN one DCM request, this is. So from where it will come, from where from tester tool to CAN IF then CAN TP, PTR, PDR, then DCM. From DCM to application it will go. Okay, this is the DCM request. In case of DCM response, diagnostic response from application, it will go to the this is how the flow here. Okay, from application it will go to DCM, DCM to PDR, PDR to CAN AF, CAN driver, and tester tool. In case of response, it will be traversing in this way. So what we are seeing is now DCM request. Okay, so that's the reason I'm coming from top to down. Okay, DCM you received, from where you received, from PDR you received it. It knows that who is the source and who is the destination. Depends on that, it will be, you can see source here is the CAN TP, destination is DCM. Okay, so if I go to the CAN TP now, sorry, if I go to the CAN TP now, here this guy CAN TP is going to receive this one. Okay, so the CAN TP is going to receive the data whichever there in the CAN with this NPD reference. So if I see this reference, these all are linked one module to other module. Okay, that is what we have discussed earlier also. So now CAN TP is going to link with the CAN IF RX. Okay, so this CAN IF, what we have discussed earlier. So CAN IF, we said like it is going to have the message ID and RX messages and TX messages, right? So you can see here RX messages and TX messages also here, apart from the general configuration. So now inside RX, so now we are receiving the diagnostic request. Okay, so here it will be there, UDS and DCAN PDU physical. So this is the message ID. For each and every diagnostics, we will be having one message ID. Okay, so that this is the message ID where we are going to receive the diagnostic request. So F9 is the tester address, 41 is the my ECU address. Okay, this is the extended CAN, which is the 29-bit identifier. Okay, got it, right? So what is the DLC and all? As per your CAN communication protocol, what is the DLC? All those things we will be configuring, and who is the RX indication to the upper layer. So from CAN AF, CAN TP is the one who is going to receive it, right? So guys, remember me guys, I was showing in the DaVinci developer. So you can see here now. So CAN TP, what is the ID? What is the ID type? And what is the DLC length and all those things, it will be showing now in the DaVinci developer configurator. Okay, so this DaVinci, this particular message will be referring with the your CAN one of the driver, so which will be there in the CAN module. So here if you see in the CAN module, CAN config set, so what we have discussed, this CAN module will be having the CAN controllers. Each CAN controller, what is the baud rates configured and all those kind of information, it will be there. Prescaler, baud rate, and propagation segment 1, propagation segment 2, SJW, all these things you might have seen in the your CAN communication class. So that calculation how we will be doing, you might have understood in the CAN communication. If you're not sure, then you can go ahead and you can read in the CAN protocol document. Okay, and one more thing is what whatever the parameter you are going to configure, if you are not sure what is that is about, then that DaVinci configurator itself, it will give you the description. Okay, you can see here if I am clicking on the seg2, then it will say that specifies phase segment 2 in the time quantas, t segment 2 equal to t seg2. What is the definition of it? What is the status of it? What is the baud rate prescaler? What is the description of that baud rate prescaler? And all those things it will be explaining here. Getting it? Concept wise, you should be very clear. That's all. Apart from that, everything it will be teaching here. If you are doing any wrong, then the tool itself, it will throw an error. Then you will be going to understand it. Okay, this is how for the diagnostics. For one particular CAN message also we will see, particularly for CAN message also it's the same actually. Apart from this, from PDR, from PDR, instead of going to the DCM module, it will go to the COM module actually. So if you see in the COM module, COM IPDUs, see this basically the signal level you can see, you can just understand one of the signal. Okay, so this is like a vehicle odometer signal. The vehicle odometer in the sense what is how much speed it is already, how much distance it is already traveled. So this particular message we will be receiving it to the COM. So this is how the if that particular message is it is about to receive every 10 milliseconds. If you are not receiving for every 10 milliseconds, what should be the replacement and all those things we will be maintaining. So depends on this VDHR, we will be having some operations will be happening in the in the application layer. If you are not receiving this message from the CAN protocol, then what should be the replacement and all, it will be there in this particular COM module. We will be configuring it. Okay. So now let me show you how to generate this. So now it is saved. Okay. See, even though if you are doing the SWC or RT configurations or whatever it will be, you should be able to generate it from only from the DaVinci configurator. So you will have the generate option here. You can see highlighted one, or else you can do the F9 function key F9. If I'm generating it, it will ask you what and all modules you wanted to generate. If you want to specifically generate only the communication modules, you can select only them. If you want to select all of them, then here the options will be there: select all, deselect all. If I'm selecting this one, only select all, it will be happening it. So if I click on this generate, then it will generate all the modules. Okay, if there is any changes, you can see now. I remember that we have done one change for one of the DID, which is F191. So now you can see that it will be going to generate it. But I'm not sure that write is having any other dependencies. It may throw an error. Depends on the project size, it will be going to take that much time. Definitely, it is having some issue with the RTE, so that's the reason it is throwing an error. So it is throwing that there is an issue in the RTE. Okay, now I need to see what is that RTE issue. In two ways you can see the issue. Either it can show at the RTE module itself if there is any error. If not, then the validation window, it will show what is that error. Okay. So here it is showing that RTE is having invoked server operation, security access unlock L1 component is invoked with set security. Okay, okay. It is some different error. Okay. I have done some changes in the RTE, which I have not yet committed for the check-in. So that's the reason it is throwing an error. But definitely, if you are trying to generate, then definitely one of the file might be get changed it. I can show you here. So this DCM and all, it got changed actually, these files actually. Guys, don't worry about this tool. I will be explaining it later about this tool. For today, I think we are most of the things are done. Let me show you what it is generated. It's not generated, but let me show you F191 how it will be usually generated. Okay. So in the diagnostic component only, it will be generated, as we already seen that this F191 will be connected as a server port to the diagap SWC. Then definitely it will be there in this one only. Already it was there in my previous project, my previous coding itself. So that's the reason I'm showing here. So this is how it is going to generate. So that was RT read port, which we created it. From DCM to the application, it will route it. If it is routing here, Then this is the manual code which I am doing it. So vehicle manufacturer issue hardware number I will be having in the application component. If you are reading this particular DID, then this is the value which it is going to print. It will be going to give you on the tester tool. Let me show you what is that value. So this is the value which it is going to show you on the tester tool. Q21 1165 001 002. That is some OEM specific value what they have wanted to have for this particular vehicle manufacturer issue hardware number. Okay, if you are reading 22F195, this value it will be coming. So I hope you all of you understood that how this will be happening in the software. Okay, got it? Did I missed anything? Any other concepts? So this all things we have covered so far. Yeah, I think apart from that, I'm quite fine for today. With this, I think I'm done most of the Autosar concepts. Can I of can driver RT is what we wanted to see. So I think we understood most of the things. So I think what is the need of Autosar and what is the importance of it in the automotive field, all of you might have understood it. Like if tomorrow, if you don't want to have any of the other software components, you can delete it. There will not be any harm. You can replace with any other software components also. You can include other software components also with other features. If you are going to change just microcontroller, then only this RT, what is this? This MCAL layer is going to change. Got it? Any doubts? Tomorrow mostly we will see at the project. Most of you guys are going to attend for the interviews and all those things, right? So let me explain the project. Hardly it may take the 2 hours. Then we will see at the tools in the next 2 classes. Okay. Tomorrow definitely we will have the classes for this project level. Okay, guys, any other doubts? If no other doubts, I think I am done for today.